Hello, today we'll be talking about machine learning, basically a brief overview of what exactly machine learning is and some broad categories of machine learning. So what is machine learning? Well, machine learning is basically a field of study where we use algorithms along with data to, in a sense, copy the way that people or humans learn. So this type of human learning allows the program to, I guess, improve over time. So the more input data you give them and the more training that they receive, then the more accurate they become. So think of it as a way a machine mimics human learning. And so in broad terms, it functions in kind of like a three-part system. So the first is it takes in some sort of input. So input, and yeah, this is usually like in the form of data or something, and it takes in the input, and then it also has it uses various or maybe just one type of algorithm to either classify the data or predict patterns in it. So it takes in input data and uses algorithms to classify. So yeah, it takes in input data and uses algorithms to classify or predict. And then two, the second part to machine learning is that you need some sort of a way to like evaluate how accurate the model or algorithm currently is. So you need a way to evaluate the accuracy, or in other words, you need some sort of an error function. So you want to, because you want to make sure that the machine is learning correctly, just like you would want to, if you're solving problems, you might be solving them wrong and you wouldn't know and you wouldn't learn that way. So you have to constantly check how well the model is performing so that you can actually allow it to improve. And yeah, so the third part is coming off of that, we have to have some sort of an optimization process. Yeah, so yeah, these are basically the three parts to machine learning. You need the input and some defined algorithms to do something with the data. And then you need to evaluate how well the model is performing. And then finally, you need to optimize it so that you can repeat the process and continually decrease the error of the machine. So there are three broad types of machine learning that I'll go over today very briefly. The first is, so one, we have supervised learning. And I'll explain this a little bit later. Two, we have unsupervised learning. And three, we have reinforcement learning. And yeah, obviously you won't know what these mean, but there are, I guess, other categories of machine learning, but these are generally the three broad categories. So let's talk more about each one. So what is supervised learning? So supervised learning, if we very simplified the whole thing, it's when you have both input, so past input and output data. So you need some sort of past. And so the whole point of supervised learning is that you have input data, and then you have, in a sense, you have like the answers or the correct points or data to the corresponding input. And so the point of a supervised machine learning algorithm is to get as close as possible to the correct output data. And yeah, this could be, there are, let's just say, maybe like predicting house prices. Let's say you have the input data of location, the year it was built, number of bedrooms, and the area, and you have historical prices, or like, I guess, the corresponding output data. So let's say you have a four-story house, or wait, yeah, let's just say four-story house, with 3 bedrooms and 100 square feet. These are just like random numbers. Then a house that was just like this might have been, let's say, $100,000. And you have another house with 10,000 square feet and one story with 11 bedrooms, and that was $1 million. So then you have the input of various variables, including the area of the house, the number of bedrooms, and the number of stories, and then you have the output, which is the price. And you're given, I guess, samples, like the two I just mentioned, and that becomes the input and the output. And then the purpose of this machine learning model is to, based on the given data and the given output data, to create a model that takes in the variables and then tries to predict the closest and most accurate output based on the data it was given. So that is, in a nutshell, like what supervised machine learning is. It's where you have labeled data. And I guess you could say, yeah. Okay, so the next one is unsupervised learning. And as you might have guessed, it's kind of the opposite of supervised learning, where instead of trying to find the relationship between the input features and the labeled data, for unsupervised learning, you're trying to find, I guess, patterns in the data. And this could be in the form of, let's say, clustering, where you're, let's say you have a bunch of different houses and you're given the price and you're given the, let's say, number of bedrooms. But you don't really have like some sort of an output data to that. Then an unsupervised learning would try to kind of cluster the different data points based on the, let's say, house area and the price. So examples are usually like clustering of something, like let's say houses based on price and area. And yeah, so for this one, you're searching for patterns in the data. So you can see like the difference between supervised learning and unsupervised learning. Is supervised learning, you're trying to kind of find the relationship between the input and the output, whereas unsupervised learning, you're trying to find, I guess, different patterns or groups within the data you're given. And finally, we have reinforcement learning. So let me make this a little bit smaller so we have space. So what is reinforcement learning? Reinforcement learning is very similar to how people like us, how we actually learn, where you're given various features for the algorithm, And you kind of, when we talked about that error or evaluating the accuracy, the way we do this with reinforcement learning is through positive or negative rewards. So let's say, example, let's say we talk about, um, I guess, autonomous driving. So or let's say specifically parking. Then for, let's say you're trying to train the computer to park correctly, and the way you can do this is allow the computer to try out parking, like simulating it somehow, and then every time, let's say it bumps into the vehicles next to it, then you get some sort of a point deduction or some sort of a negative reward. And if they're successful, then they get some sort of a positive reward. Then the reinforcement learning algorithm is going to try to, obviously, like just like us, it's going to try to maximize the positive rewards, and in this way, it's going to gradually become better at parking. So let's just say it's a reward system. And yeah, these are just very broad definitions, or yeah, you can think of it as like an overview of these machine learning categories, and I'll be going over them in detail in the next videos, but this is just an introduction. So we have supervised learning, which has the label data and the input features. Then we have unsupervised learning, which searches for patterns within the data, so you're not given exactly what you're looking for, but you're rather searching for, it's kind of like you're giving the algorithm freedom to search patterns on its own. And the reinforcement learning use a reward system in which the algorithms are rewarded for usually something that is classified as high risk. Then they get the reward, and you're basically reinforcing the model by rewarding them when they do something correctly. And yeah, that's it for today. I'll be going over these in detail as well as other categories in future videos. Thank you for watching.